Hello. Welcome back to the fourth video on this channel. In this one, we're going to be talking about some physics. We're going to dive pretty deep into it immediately. We're going to be discussing a version of M theory, which is a continuation of string theory. We'll be discussing all the technicals later. We won't be getting too deep mathematically, but the majority of this video is just a hypothesis that I came up with a few months ago. Just kind of throwing stuff at the wall, seeing for stakes, Really, I have some math for it, but it's kind of offensive to call it math, honestly. It's just, just explaining it in mathematical terms, just so it looks fancy. So I have a rough draft paper that I'm not going to use as a script, obviously, because that'd be really boring. But we are going to be discussing it in total. And so, let's begin with my hook segment of my script. So, in biology, osmosis is the force that keeps cells alive. It's a process by which molecules of a solvent tend to pass through a semi-permeable membrane from a less concentrated solution to a more concentrated one, which equalizes the concentrations on each side. Scientists have struggled for decades with two massive physics problems in modern physics. These two are, why is gravity so incredibly weak to other forces, and the other being, why is the vacuum of space pushing itself apart at an accelerating rate? Alright, so, the name of these terms, well, actually, let's get into the first one. Why is gravity so weak? I'll use an example. Well, this is called the hierarchy problem, because, the hierarchy of the fundamental forces. So, why can, say, a Cookie Monster fridge magnet overpower Earth's gravity? Why doesn't it fall to the floor? Why is magnetism at such a small level so much stronger? And why is a force literally called the weak force stronger than gravity? That's one big issue. Second big issue is the cosmological constant problem, which is also called the vacuum catastrophe. It's a massive discrepancy up to 1 to the 120th orders of magnitude between the predicted energy density of empty space coming from quantum field theory and the observed small positive value of the cosmological constant accelerating in the universe expansion. This mismatch is considered the worst theoretical prediction in physics history. And in this video, we're going to be exploring an exploration of M theory through a hypothesis that I call the cosmic osmosis hypothesis. The hypothesis builds off the Randall syndrome, or RS model of M theory, which will be explained momentarily. And when we refer to the Randall syndrome, I'm butchering your name, I'm so sorry. But Randall syndrome model, we're going to be referring it to as the RS model for just simplicity. So, to begin, let's talk about where this model comes from. The cosmic osmosis hypothesis takes place in, like I said earlier, an M theory universe. M theory is a theoretical framework in physics that unifies all 5 superstring theories and proposes an 11-dimensional universe, which incorporates strings and higher dimensional objects called branes. The two large aspects of this is, I got a whiteboard for this, is the branes. Brain spelled B-R-A-N-E, not, this guy. But it is two, also, the 11 is for physical dimensions. We are in a 3 physical dimension universe. We have the 3 physical dimensions, and then if you hear that we're in a 4D universe, the 4th dimension they're referring to is time. So, 11-dimensional brain, that is called the bulk. That is, you can imagine us like a marble, in the M theory, in M theory, we are, we're like a marble in a balloon. The balloon being the 11-dimensional brain, and obviously us is the marble in the 3-dimensional brain. I'll explain what all these lines mean. I kind of did a take of this video earlier, and so I just went at it, but we'll also be putting up probably images around the screen later on. I'd also like to say that when we speak about gravity in this video, for the majority of the time, we will be talking about the theorized graviton, which is a hypothetical quantum of gravitational energy, which is regarded to as a particle. Traditional M-theory models, such as the RS model, RS framework, says that gravity is so weak because it leaks out of our universe through tiny Planck-sized holes. So, our universe being the three brain, gravity, or the gravitons, will leak out of our universe through little Planck-sized holes going into the 11-dimensional brain. This is a hypothetical solution to the hierarchy problem, saying that the reason gravity is so weak is because it is leaking out of the 3-dimensional brain into the 11-dimensional bulk, or the 11-dimensional brain. But for the most part, we'll be referring to this as just the bulk. The cosmic osmosis hypothesis suggests that if stuff is leaking out, stuff is also leaking in. The hypothesis theorizes that there are pores at the edge of the 3-dimensional brain, same ones that leak the gravitons out, and they are at Planck scale, which is the smallest possible size in physics. Because the bulk is packed with high-density vacuum energy, and a universe is relatively empty of said energy, the energy naturally flows into a universe to balance pressure, hence the osmosis and the cosmic, since, dealing with cosmos here. To turn this hypothesis into leaking energy in a physical model, we use the concept of trans-dimensional pressure. In your typical classroom environment or just studying osmosis, you study the movement of, solvents across a semi-permeable membrane to each other through a concentration gradient. In this model, the movement is driven by a potential gradient between the high energy density of the bulk, which will be represented as P bulk, and then in the lower density 4-dimensional universe, or 3 physical dimension, just like to clarify that, universe that we live in will be represented as this. So in the equations we see throughout, this is just the pressure in the bulk, and this is just the vacuum pressure in our 3 physical dimensional universe. I will likely throw a more formal, photo of the formula up, but right now, the main formula for the expansion is labeled as P trans equals kappa, rho bulk minus rho OBS. What this these two, rho bulk and rho OBS. Rho is just the proper term for the P, but at times we'll probably just call it P. These represent the vacuum energy density of the 11-dimensional bulk versus our observed 3-dimensional space. Because the bulk's energy is so much higher, it creates a push in our universe. When the energy of the 11-dimensional bulk, P bulk, comes into ours, it's the push. So just the subtraction, is the push. The K is pronounced kappa, or kappa, one of the two. I think kappa. And it's a coupling constant. This is the gatekeeper, and it represents how easily energy can move based on the brain tension, represented as a lowercase sigma, which I'll pop up on screen or highlight, of one of those Planck scale pores. If the brain is tight or pretty closed, or the pores are small, the kappa is low, and energy trickles in slowly. But how much energy is actually coming through? Well, we call this the flux. You can think of this as the flow rate of the energy. In this formula that is put on screen, the n pores is the density of those Planck scale apertures or pores across the fabric of space, and the L squared, and beside it is the area of each individual pore at the Planck scale, which is 10 to the negative 35 m. V flow is the inflow velocity, or how fast the vacuum energy is rushing in, which is driven by that gradient that we mentioned earlier. Here is the part of the theory that covers the cosmological constant problem. Usually the energy density that we observe is billions of times smaller than that quantum physics says it should be. Cosmic osmosis suggests that the expansion of our universe is directly proportional to this inflow, which is represented by this equation. This equation is saying that the expansion of our universe is directly proportional to its inflow, which is represented as the flux and the transdimensional pressure that we got from the first equation. As energy flows into our lower density universe, the internal pressure increases. To maintain this equilibrium and keep the quote unquote, in the osmosis term, the cell, or just our universe, from bursting, the universe performs the mechanical work by just expanding. This means that the cosmological constant isn't a fixed number, but it's just an emergent property. It's more liquid. It moves, which is represented by this equation. The 3 is for the three-dimensional universe that we're in. And by tying dark energy to this trans-dimensional exchange, rather than a static value, we explain why it's so small. It's simply limited by the pore size, the tension of our universe's membrane. So how does this fit with the Randall-Sundrum, or the RS model that we mentioned earlier? In the RS model, the extra dimension is warped. This warping is what prevents our universe from being instantly flooded by the bulk's energy. I'm avoiding the conversation of anti-de Sitter space for, simplicity, but I could make a video or a short, YouTube short on it if you guys would like to do a brief overview of that. But it's just the geometry of the universe, the M-theory universe. And in our hypothesis, this warping acts like an exponential filter, suppresses the inflow velocity, or V flow, by allowing it just enough energy to drip into the tiny amount of dark energy that we see today. It turns the 120 order of magnitude, the mismatch of that we talked about earlier, in standard physics into a simple balancing act between the two different dimensions, hence the cosmic osmosis. And so that's the gist of the theory. It's not too sound yet, but it's getting there. When I, finalize the paper more in a bit of time, I will probably put a link to it on my YouTube channel or something of the sorts. But that is the video for us today.